what are we discussing? We are discussing about the layering on the basis of temperature pattern. These are the layers, the troposphere, stratosphere, mesosphere, and thermosphere. And now we are writing about, we've seen how the temperature reduces, increases, reduces, and further increases. Now, moving on, write about troposphere. Write about the troposphere. The height is about 8 to 18 kilometers. 8 kilometers at the poles, whereas at the equator, the height is more, around 18 kilometers. The reason for the variation in the height is because of the insolation and the vertical air currents. Okay, so because of the insolation. Okay, example, you can write equator gets heated more and therefore has greater extent of the vertical air currents. At equator, okay, this is pole, this is equator. There is a greater amount of heating, there is greater air currents, and because of this, the height of troposphere is 18 kilometer here, whereas it is 8 kilometer at the poles. Okay, this is your troposphere. Greater insolation, greater extent of the vertical air current, and therefore the troposphere is higher in height at the equator as compared to the poles. Above the troposphere, you have a lid. You have a lid called as the tropopause. If you look at the word of troposphere, if you look at the word troposphere, okay, tropos means what? It means turning away. It means a turning away. So what is happening here in troposphere? If you look at troposphere, the air current is rising. It reaches a layer and then it turns away. So that is why, if you look at here, this is the air current. The air current reaches up to tropopause and then it turns away. So beyond tropopause, do we have vertical air currents? No. If we do not have vertical air currents, can we expect weather? Why do you have clouds? Heating, air rising, cooling, clouds, or condensation, precipitation, other things happen, right? If we do not have air currents beyond a particular layer, there will be no weather activities there. So troposphere, the word has been derived from the word tropos, which means what? Turning away. So here the air rises up to tropopause and then it turns away. That's what happens in your troposphere. So tropos, the word is tropos, which means turning away, and it generally marks the highest extent of air currents. So tropopause ke upar, there will be no vertical air currents. So tropos means, the word means turning away. It means turning away. Don't write the word pole. It means turning away. And it generally marks the highest extent up to which the air current can exist, beyond which you do not have vertical air currents. So here we are doing troposphere. The height is 8 to 18 kilometers. The height is more at the equator because of the insolation and the air current. Troposphere is the weather layer, that is all the weather related activities are confined to this layer. All the weather related activities are confined to this layer. In troposphere, we are looking at, this is a weather layer. All the weather related activities are confined to this layer. Now, it is if you look at troposphere, abhi tak what have we seen? I'm looking at troposphere. At troposphere, I said that the height of troposphere is more at the equator and is less at poles. So this is pole, this is equator. The height of troposphere is more at the equator. If that is the case, and we've also known what happens in the troposphere. In the troposphere, the temperature reduces with the increase in the height. The temperature reduces with the increase in the height. If this is, the temperature is 100 degrees Celsius of this layer. If the temperature is 100 degrees Celsius, as you move higher in the height, okay, the temperature is reducing. Now, whether at point A or whether at point B, where will the air be cooler? जितना हवा दूर जाएगी उतनी ज्यादा ठंडी होगी क्योंकि नीचे से गर्म होती है. Do you know how does your atmosphere cool? The atmosphere, if this is your earth, okay, if this is your earth and this is your atmosphere, this is sun. Does your atmosphere get cool like this from above to low, or the earth or the atmosphere gets cool like this, warm like this? Aapka atmosphere, how does it get warm? From point A to B or from B to A? B to A. So if the atmosphere gets warm because of B to A, the layer which is near to the surface should be warm. As you move away from the surface in troposphere, I'm just talking about troposphere for now. Okay. As you move away from the surface of the earth, the air should cool. As you move further away, the air should cool more. So if this is 8 kilometers and this is 18 kilometers, oh, where do you think the air would be more cooler? At point B. This is the heat source. This is the heat source. It is the Earth's surface that acts as the heat source. Now, why does this happen? Now, I'm explaining you two concepts. We will write all this. What is happening? The Earth's atmosphere is cooling in troposphere. In troposphere layer, the Earth's atmosphere is cooling from your Earth's surface, from the Earth's surface, that is from top to above, from below to top, and not from top to below. One. Why is this happening? Is because if you look at the Earth's atmosphere, okay, we have certain gases called as the greenhouse gases, which are examples like CO2, water vapor. Now, this greenhouse gases, they are transparent to the incoming radiations. They don't absorb. If this is the sun, these are the incoming radiation. These greenhouse gas, they do not absorb these incoming radiations. Who absorbs that? Earth's surface. And then what does Earth's surface do? It absorbs the gas, it absorbs the heat. As it absorbs the heat, then it later radiates those heat. So this incoming radiation, they are of short wavelength. Okay. And the Earth's surface that is radiating the heat is of long wave radiation. And once the Earth now radiates the heat, the greenhouse gases will absorb them. Therefore, and we also know one thing, the atmosphere is more dense at the bottom. The Earth is less dense. So at the bottom, there will be more greenhouse gases. At the bottom, the heat is also high because the source is Earth's surface. And therefore, here, it will be more hot. As you move away from the source, as you move, jitna dur jaoge, utna Earth ka atmosphere cool hoga. In what? In troposphere. I'm just talking about troposphere for now. Now, understand, appreciate one more thing. If you look at composition, 78% is nitrogen, 21% is oxygen. That means 99.9% of the atmosphere is not involved in this heating. Nitrogen is not a greenhouse gas. Oxygen is not a greenhouse gas. So 99.9%, 99% of Earth's atmosphere is not involved in this heating. It is 1% of the greenhouse gases that is responsible for the heating of the atmosphere. If you understand this question, You will be able to relate to what has been asked in your GS mains examination. This year, they have asked a question on troposphere. That troposphere is the most significant weather layer. Some kind of question has been asked, and how has been asked. How or why, that has been asked. Okay, so this is just a basic idea about what is happening in your troposphere. In the temperate countries where there's not of sunshine, बहुत sunshine होती नहीं है, क्योंकि sunshine होती नहीं है. Or you can also see if you would have traveled in car in summers, अगर कार बहुत धूप में पड़ी हुई है और बंद है, ठीक है, the moment you enter, there's lot of heat that you can feel. So what is happening? Your greenhouse gases जो कार के अंदर है, वो absorb कर रही हैं. किससे? ऊपर से नहीं, जो heat सीट दे रही है, जो हीट स्टीयरिंग दे रही है, जो हीट डैशबोर्ड दे रही है, राइट, वहां से. तो व्हाट इज हैपनिंग इज दिस इज योर सन. ओके, दिस इज रेडिएशन दैट इज कमिंग. दिस रेडिएशन इज नॉट एब्सॉर्ब्ड बाय द ग्रीन हाउस गैसेस बिकॉज दे आर शॉर्ट वेव रेडिएशन. दिस वन एब्सॉर्ब्स इट, दिस वन एब्सॉर्ब्स इट, and then when it absorbs, it re-radiates it. These are what? Long wave. And this long wave is absorbed by the greenhouse gases. Okay, so what is this called as? The greenhouse effect. Now, 1% of the atmosphere, CO2, CH4, water vapor, okay, SF6, these are responsible. Now, why are we concerned? Because what are we doing? Human is increasing this carbon dioxide. How? By burning the fossil fuels. And now if greenhouse gases increase in the atmosphere, what will happen? You will have enhanced warming. That is called as enhanced greenhouse gas effect. The enhanced greenhouse gas effect. Okay, right? Third point, the temperature at Tropopause is about minus 45 degrees Celsius above poles and minus 80 degrees Celsius at equator. Fourth point, greenhouse gas effect. The greenhouse gases in the troposphere are transparent to the incoming, to the short wave incoming solar radiation. In bracket you can write, therefore the troposphere does not get heated from above. They are transparent to short wave incoming solar radiation but are opaque and therefore absorb the long wave terrestrial radiation. The radiation emitted by Earth's surface after absorbing the solar radiation. After absorbing the solar radiation, and therefore the troposphere gets heated from below. Now you understand why is the temperature reducing as we move higher in the height in the troposphere. The temperature, what is the pattern? The pattern is the temperature reduces with the increase in the height in the troposphere. Quick revision of what have we done. The temperature falls in the height. The temperature is minus 80 degrees Celsius on equator, minus 45 degrees Celsius at the poles on the tropopause. There is difference in the height. It is 8 kilometers at poles and 18 kilometers at equator. The thickness is greater at the equator. The height is greater at the equator because of the convectional currents, the vertical air currents. The equator gets heated more and the heat is transported to greater height by this. Okay, this is also called as the convective region, since all the convection stops at the tropopause. All the convection gets stopped at the tropopause. Then the temperature is less over the equator as compared to the poles in troposphere because the temperature falls as you move higher in the height. This is the meteorologically the most significant layer. All the weather related activities like cyclones, rainfalls, precipitation, fogs, hailstone, they are confined into this layer. So this is your troposphere. Then moving on, we have a stratosphere, the second layer, stratosphere. This was about 8 to 18 kilometers. The height of a stratosphere is 50 kilometers. Extends up to 50 kilometers. Here what is happening? The temperature increase with the increase in the height. And why is this happening? Because of the presence of ozone. The ozone absorbs the UV radiation. Radiation. If you look at this layer, okay, this layer, which is the layer called as the tropopause. Tropopause. Or if you also look at the lower layer of the stratosphere. Okay. You look at the lower layer of the stratosphere, these two layers, the tropopause and the stratosphere, lower layer, they are the zone of calm. Calm. Yahan pe there is no rising air currents and they do not have any weather related activity. And therefore, this zone is called as a zone of calm. Now, if this is a layer, okay, where there's all the vertical extent and weather activity taking place, and this is a layer above it, where there is no vertical activity or where there is no weather activity going on, where as a pilot, where will you fly your plane? Here or here? At a zone of calm. So where do the airplane get flown? It is either at the tropopause or at the lower layer of the stratosphere. Therefore, when you are having a flight, you can see the layers of the clouds below you, and you are flying over the layer of the clouds. So please write that the lower part of a stratosphere and tropopause are zone of calm condition, and therefore the airplanes fly in this zone. This is what is your stratosphere. The stratosphere, a layer above the troposphere hona chahiye. Layer above troposphere, the temperature increase with the increase in the height, reach a level of the temperature reaches a level of 0 degrees Celsius at 50 kilometers. We said that the temperature is increasing with the increase in the height, and the temperature becomes 0 degrees Celsius at 50 kilometers. The temperature becomes 0 degrees Celsius at 15 kilometers. So if you look at troposphere, if I'm studying, let's say above the equator, what was the temperature here? Minus 85 degrees Celsius. And in the stratosphere, the temperature is increasing and it is becoming 0 degrees Celsius at the 50 kilometer. The temperature is becoming 0 degrees Celsius. Why is the temperature increasing? The temperature is increasing because of the presence of ozone. What do ozone do? It absorbs the incoming UV rays from the sun, the ultraviolet rays from the sun. As it absorbs, therefore the temperature increases in the overall stratosphere. Ozone is present nearly entirely in your troposphere, in your stratosphere. But though the ozone is scattered entirely across your stratosphere, but there is a particular zone at about 30 kilometers where there is higher concentration of the ozone. And this layer is also called as ozonosphere. Ozonosphere. What is ozonosphere? Ozonosphere is basically a layer within the stratosphere. Where there is a greater concentration where there is a greater concentration. This ozone is absorbing UV radiation. This ozone is absorbing UV radiation. Now understand, there is ozone in the stratosphere. Okay, the ozone in the stratosphere. What is the ozone in the stratosphere doing? Right? The ozone in the stratosphere is absorbing UV radiation. Therefore, as it absorbs, it prevents the harmful UV radiation to reaching on the Earth's surface. Now, in this ozone, because of your chlorofluorocarbons, we have ozone hole that is getting formed. That is, ozone is a very dynamic gas. Okay, ozone बहुत dynamic gas होता है. If you look at ozone, ozone always goes a process. ये process होता जाता है. ठीक है. अब if we release CFCs, okay, it destroys this ozone. As it destroys this ozone, there is a hole that is created. Now, because ozone was absorbing this harmful UV radiation, now if there is a hole in the ozone layer, what will happen? There would be no absorption of this harmful UV radiation, and the harmful UV radiation would reach what? The Earth's surface, which increases the possibility of causing cancers, skin cancers, eye infections. So that is why the ozone in the stratosphere is a good ozone. But there is an ozone that is also present in the tropopause. That is caused because of the pollution that we do. This is given in your class 11 NCERT, Environmental Chemistry, Part 2, Chapter 14. Okay, ozone hole, formation of ozone hole, good ozone, bad ozone, ozone at the troposphere, right? So, जो ozone troposphere में होती है, वो pollution के कारण बनती है. That is a bad ozone. Now, the rise in the temperature is because of the presence of ozone, okay, because it absorbs your harmful UV radiation. This layer, the layer of the lower stratosphere, is free from the clouds, and therefore it makes the most ideal conditions for flying the airplanes. Therefore, the airplanes, they fly in the lower stratosphere or sometimes in the troposphere where the weather is calm. Then we have the ozone layer. The highest concentration is between 20 to 30 kilometers. So where you've written ozonosphere, right? The highest concentration is between 20 kilometers to 30 kilometers. जहाँ पे ये लिखा है, ठीक है? The third layer is mesosphere. What is happening in mesosphere? The temperature further reduces with the increase in the height. Okay. The temperature is about minus 90 degrees Celsius to minus 100 degrees Celsius at about 80 kilometers. This extends, mesosphere extends up to 80 kilometers. The meteor, right, they burn in this layer. It is the coolest layer. Meteorite, they burn in this layer. It is the coolest layer. Okay. Now, in this layer, the layer is too cool. Okay. The layer is too cold. And the meteor also burn in this layer. So the layer is too cold, plus the dust from meteors. So meteor hai, so dust aa rahi hai, burn ho raha hai, dust ho rahi hai, and the layer is very cold. So the meteor dust, they settle on this cool air particles, and it forms a special type of clouds. It forms a special type of cloud called as the noctilucent cloud. Noctilucent clouds. It is not a cloud in the cloud sense. ये बारिश नहीं देगा. It will not give rainfall. Okay, but it is just that the dust particles, they have settled down on the cooler air molecules. Okay, the cooler air molecules, the dust have settled down. Now, this is your mesosphere. Why are meteor burning? The meteor burns in this layer because of the friction offered by the air molecules. Now, what is happening here? this layer is too cold. Mesosphere is too cold. Plus the dust from the meteor. So this dust from the meteor gets condensed around the cooler air molecules. As it gets condensed on the cooler air molecule, you have a special type of cloud called as the noctilucent clouds. Okay, this is a cloud that will not bring rainfall. It is not a typical cloud, but it is just the condensation of the dust particles. What is a cloud? Cloud is where the dust particles, even in our troposphere, the dust particles, they are getting condensed on the hygroscopic nuclei, yeah, some cool particles, and therefore over the time there is more absorption of the water, and over the time when the air is unable to hold that water, the water falls down. That is your typical cloud. So that brings rainfall. But here what is happening? The dust from the meteor is getting condensed on the cooler air molecule, forming your noctilucent cloud. Mesosphere is more dense as compared to thermosphere. Mesosphere is less dense as compared to stratosphere and troposphere, right? This is what is happening in your mesosphere. So a quick revision of a mesosphere: up to 80 kilometers. All the meteor burn up in this layer before entering, from entering the space. The temperature reduces with the increase in the altitude, and the temperature can go up to as minus 100 degrees Celsius. Okay, this gets form your noctilucent cloud. The dust from the water vapor is getting condensed on the air molecules, forming your noctilucent cloud. Okay, moving on to the third layer, that is your thermosphere. Okay, the temperature increases with the increase in the height. It actually, there is no particular, generally said up to 400 kilometer, but it eventually merges into space. So you can write it extends up to 400 kilometer, extends up to 400 kilometer, and eventually merges into space. The atmosphere is extremely rarefied. If we take into consideration on the basis of relative mixing, up to what kilometer we had homosphere? To 80 kilometer we had homosphere. And above that, what we had? We had hydrosphere, where what was happening? The gases, they were layered. The gases, they were layered. The lower gases were N2O2 and the above was HNHe. So in your thermosphere, what is it? Thermosphere is a part of hydrosphere. We have layers of the gases. Okay, so hydrogen or helium तो वैसे भी बहुत ऊपर है. And these are what? Very light gases. And the atmosphere is also very rarefied. So we don't know exactly where is thermosphere getting over and where is your space beginning. Okay, so this is your thermosphere. It is a very rarefied, it is an atmosphere is very extremely rarefied, and therefore no heat is felt in this layer. Temperature बहुत high है, but heat नहीं feel हो रहा है, because heat feel होने के लिए air molecules होने चाहिए, right? If there are very less air molecules, you will not feel the heat in this layer, but the temperature is extremely high. Also write about a special feature, Kármán line. It is around 100 kilometer. Around 100 kilometer, you have Kármán line. Exosphere is considered to be a part of thermosphere, or sometimes the book also write exosphere as separate Shivendra. Okay? And this is considered. It is considered that beyond Kármán line, the space starts. Kármán line is considered to be the greatest extent of atmosphere. Greatest extent of atmosphere. That's what is considered for your Kármán line. It is defined as a boundary between Earth's atmosphere and outer space. Okay. If you look at the satellites, where are satellites kept? They're kept in this layer, your thermosphere layer. If you look at another special feature for thermosphere is also the reflection of the radio waves. So those special features, like we have seen a special feature for all of the layers. Troposphere is a weather layer. Stratosphere has ozone. Meteors burn in the mesosphere. In your thermosphere, so you have thermosphere has ionosphere. Has what is ionosphere? And nothing but the ions of gases. Why do we have ions of gases only in this layer? Because it is a part of heterosphere. समझ रहे हो आप connections are? It's a part of heterosphere. The layers are there are gases layers. There are ions. The ions that is a part of ionosphere. In bracket you can write a part of a heterosphere. Okay. Thermosphere reflects radio waves. The International Space Station and a satellite orbit in this layer. They orbit in this layer. Okay. Achha, one more thing that you can see in thermosphere is the auroras. You know now what is auroras? What is happening in auroras? The solar radiation, they are getting in touch with what? The ions, the various gases, and therefore we observe auroras. So auroras are observed in this layer. Auroras are what? What is auroras? Basically, auroras are bright lights. Okay? These are bright lights. How are these bright lights seen? Because there is interaction. Interaction between what? The solar radiation and Earth's magnetic field. अर्थ की मैग्नेटिक फील्ड जो है वो तो पूरे अर्थ सरफेस से लेके अर्थ के ऊपर तक है. So, सिर्फ इस लेयर की बात नहीं है. ये मैग्नेटिक फील्ड लाइंस जो है ये इंटरैक्ट करेगी विथ द सोलर रेडिएशन. हाउ वेयर डू यू ऑब्जर्व? इन विच लेयर? इन विच लेयर डू दिस अकर? इन थर्मोस्फेयर. ठीक है, getting the link, and we can see them up to in our poles also. From poles here they are fairly visible. When you are at the poles, you can observe these auroras. But where are they taking place? In which layer? They are taking place in the thermosphere. Okay. This we've already seen, the electromagnetic spectrum, the electromagnetic radiation. If you look at the electromagnetic radiation spectrum, it is composed of gamma rays, X-ray, UV, ultraviolet, visible, infrared, microwave, and radio wave. The short form is GXUVIMR. Gamma rays, X-rays, ultraviolet, visible, infrared, microwave, and radio waves. Here, as you move along the right, what is happening? The wavelength is increasing. And what is happening to frequency? The frequency reduces. Okay. So just know for a fact, GXUVIMR, radio wave has the greatest wavelength and has the lowest frequency. Okay. Now, yes. With this information that you have, can you please solve this question? The aircraft fly very easily and smoothly in the lower stratosphere. What could be the possible explanation? One, there are no clouds or water vapor in the lower atmosphere, in the lower stratosphere, and there are no vertical or winds in the lower stratosphere. Is pe doubt nahi hai. There are all the weather activities, water vapor, clouds, they are confined to which layer? Troposphere. So there in the lower stratosphere, we do not have any cloud or water vapor. Jitni bhi weather related activities hain, water vapor, clouds, your cyclones, precipitation, condensation, they are there in the troposphere. This is your answer is C. A layer in the Earth's atmosphere called as ionosphere facilitates radio communication. Why? Because of the presence of ozone that causes the reflection of radio wave to Earth. Second, the radio wave has very long wavelength. Where is ozone present? Stratosphere. Ionosphere is a part of what layer? So how is the presence of ozone causing the reflection of the radio wave on Earth? So ozone is present in stratosphere. Ions that are there, that will become your ionosphere. The ionosphere is causing reflection of the radio waves. So presence of ozone is wrong. And this radio wave has very long wavelength. You see GX, UV, IMR. Radio wave have very long wavelength. Okay. So B, that is 2 only. Yes. Normally, the temperature decreases with the increase in the height from the Earth's surface because when I say moisture, can I replace this with water vapor? Water vapor is what? Is a greenhouse gases. If this statement is correct, then what will happen? The temperature should be more in the upper atmosphere. Samajh aa raha hai? So this would defeat the very one purpose of because. Moreover, if gases are more below, water vapor also should be more at the surface, not higher. Stratosphere may have no water vapor, no? So there is more water vapor where? Below. And even if this is correct, for a second, if I say even if this is correct, this will defeat the whole purpose of because. So the answer is 1 and 3 only. Is it fine, all of you? This is about majorly about when it say increase in the height, decrease in the increase in the height. Obviously, this is not about a stratosphere, because in stratosphere, what happens? The temperature increases with the increase in the height, and therefore this should be a troposphere majorly, right?